The Salmon Solution. The eggs we got in January hatched into alevin and now they're fry. Pretty soon we'll be releasing them into the Clear Creek ecosystem. Will Clear Creek be a healthy habitat for our salmon fry? Well, what is a healthy habitat? A habitat is where an organism has water, has shelter, and has food. Let's start with water. Salmon need the 3 C's. The first C? Cold water. Salmon use their gills to absorb oxygen from the water. Cold water holds more oxygen. The second C is clean water. Polluted water can make salmon sick or even kill them. Polluted water can also affect a salmon's sense of smell and make them more vulnerable to predators. The third C is clear water. Too much silt can make water cloudy. This can make it hard for the salmon to find food. Silt can also cover up salmon nests, which cuts off oxygen to the eggs. Finally, silty water can clog a salmon's gills. Salmon much prefer clear water. Let's move on to shelter. Salmon need woody debris in their habitat, like this. Woody debris can be things like fallen trees and branches. Woody debris slows down the stream. It forms pools and serves as a hiding place for small salmon. Salmon habitats also need rocks and gravel. Rocks and gravel are important because when water flows and bumps over rocks, oxygen is added to the water. Salmon also lay their eggs in nests of gravel, and it provides a hiding place for small salmon. Lastly, food. What do salmon fry eat? The answer? Benthic macroinvertebrates. What does that mean? Benthic means bottom dwelling. These macroinvertebrates live at the bottom of the stream. Macro means they're large enough to see without a microscope. Invertebrates means they don't have spines, but we know them as a different name. Benthic macroinvertebrates are stream bugs. Stream bugs are things like the larvae of stoneflies, caddisflies, and mayflies. Salmon fry eat these stream bugs along with some land bugs that happen to fall into the water. This is Clear Creek. It's the exact location where we will be releasing our salmon. Does it look like a healthy salmon habitat? What do you see that might make a good home for our salmon? You might have said water. I can assure you that this water is very cold. It runs about 44 degrees this time of year. You might have also said woody debris, but what about food? It's hard to see it, but there is food here. Land bugs. Some of these land bugs may end up falling into the stream, becoming food for young salmon. These land bugs live in something called the riparian zone. Riparian is a word that means the area around the stream, and this riparian zone is very important to our salmon. A good riparian zone has trees, lots of them. The trees provide shelter and shade, and they also have leaves that fall into the stream. Why are the leaves important? Well, they provide food for those benthic macroinvertebrates, and we know those are what our young salmon eat. Here's a picture of Clear Creek taken from the riparian zone, right near where you'll be releasing our salmon. Do you see anything here that might be good for our salmon? Maybe you said shade. Imagine if this dark corner wasn't there. What if it was sunny instead? If a stream gets a lot of sun, it gets too warm. Remember, salmon need very cold water to carry lots of oxygen. If it's too warm, a salmon can't breathe. Yes, the trees in the riparian zone do a lot of good things for our salmon. What do you see in this picture? Another view of the release location. Do you see all that brush in the riparian zone along the stream bank? When it rains, and it often rains, this brush slows down the flow of water that reaches the stream. Why would it be important to slow down the flow of water entering the stream? If you don't, you might end up with something like this. What's wrong with this habitat? Did you say it's cloudy or silty? You're right. Remember that salmon need clear water to survive. When there's no brush along the stream banks, all the rain that falls just washes the soil right into the stream. It's called erosion. This muddies up the water, which, as we know, is not good for salmon. We want to protect our stream from erosion so we don't bury eggs or make it hard for salmon to breathe with their gills. Here we are back at Clear Creek. When we're on location, we don't want to get too close to the stream. We don't want to trample and kill the brush, causing erosion, so we won't be standing here. That leads us to a problem. How are we going to get our salmon into the stream? We can't reach the water without harming the riparian habitat. If we stand on the bank, it will cause erosion. If we get too close, the bank may collapse and students could even get hurt. Scientists and engineers like to use problem statements. Something like, how can we blank in such a way that blank? In this case, our problem statement would be, how can we release our salmon fry in such a way that we do not harm the salmon habitat, or students? That brings us to the engineering challenge. Remember that engineers use creativity and math and science to solve problems. Engineers create technology. You and your team will design a new technology to release salmon fry without having to harm the salmon stream habitat. We're going to follow the steps of the engineering design process. The first step is ask. What is the problem? What are the success criteria and the constraints? The second step is imagine. You'll brainstorm ideas and choose the best one. The third step is plan. You'll draw a diagram and gather the materials you think you'll need. The next step is create. You'll follow your plan to build your technology and then test it out. The fifth step is improve. What could work better about your design? Then repeat steps 1 through 5. Remember, we're designing a technology so we can get our salmon here without harming the habitat, without standing in the riparian zone, without falling into the stream, and without harming our salmon. So let's start with the first step of the engineering design process. Ask. What questions do you have about your challenge? We'll be answering these questions and more as we move on to the next phase of our engineering design process.